Hi everyone, this is Kishore. Please subscribe my channel for more videos. Okay. So today we are going to discussing about Ohm's law as well as law of resistance. Okay, Ohm's law as well as law of resistance. Law of resistance are also called as property of law of resistance. Property of law of resistance. Okay, law of resistance. Okay. So coming to the Ohm's law, okay. So coming to the Ohm's law, without Ohm's law, there is no electrical system is there. Without Ohm's law, there is no electrical system is there. Okay. Why? Because the based on this Ohm's law, so based on the electrical parameters like either voltage or current or coming to the mechanical temperature, both these three parameters like temperature, voltage and current, which is there are slightly different types of variations may be consisting. So that is regarding by the explanation by the Ohm's law. That is only possible. That is only possible by the Ohm's law. Okay. Without Ohm's law, we can't measure the both voltage and current as well as temperature variations. Okay. So there are different types of variations. Okay. So that is mainly based on the Ohm's law. That is mainly based on the Ohm's law. Okay. As well as coming to the law of resistance, so depending upon the law of the property of resistance, the conductor size is depending upon the property of resistance or law of resistance, the conductor size is depending. So for example, if you want to measure the length of the conductor is like either 100 km or 150 km or for example like 200 km, whatever may be that. So that is the total length as well as total area of cross section of that particular conductor or line may be depending upon the property of resistance, property of law of resistance. Okay, so these are the different types of resistance is there according to from the Ohm's law as well as law of resistance. Okay, so coming to the first of all Ohm's law. Okay, Ohm's law definition. Coming to the Ohm's law definition. So let us consider first of all, if we want to take one conductor, okay, this is the conductor. Here conductor is like a solenoid. Okay. See here solenoid means, so this is like an iron pipe. The pipe which is wooling of copper. The pipe which is wooling on copper. Okay. So whenever supply is given to the pipe, solenoid, here pipe means solenoid. Whenever the supply is given to the solenoid, then some flux will be existing. Due to the flux, so finally output will be some current will be existing. So this is the different reason. That is the different criteria. So coming to the Ohm's law, so at constant temperature, so which is very important. At constant temperature means, okay, at constant temperature, the current which is directly proportional to the potential difference across the conductor. So this is the total conductor. Okay, so this is the total length of the conductor. So the length of the total conductor is like L. The total length of the conductor which is given as some L. Okay, so at constant temperature, the current which is directly proportional to the potential difference across the conductor. So that is given as V. Potential difference means that is like a voltage. Already know that, I think. So the potential difference across the conductor, that is given as V. So therefore from I is directly proportional to V. So this is called as Ohm's law. So if suppose the Ohm's law which is applicable, the machine should be contains at constant temperature. Okay. So for example, if suppose the temperature will be rising, then at the time the Ohm's law is not satisfied. At any elements like a diodes or some resistance or different types of bulbs like fluorescent lamps or different types of lamps, at any time, at any conditions, if suppose the temperature will be rising, at that condition the Ohm's law is not applicable. Okay, so basically the Ohm's law which is not applicable for the best example for the like a voltage regulator. So Ohm means at that, so basically the temperature is not maintained constant. Okay, voltage regulators as like a non-linear devices, whatever may be that. Non-linear device means which is doesn't depending upon the time, Okay, so with respect to time which is not depending on the temperature will be, so with respect to time it will be gradually rising. Okay, so both temperature as well as time not equally rising. Okay, so with respect to time the temperature is so inversely proportional to rising. Okay, so that is the So that is the non-linear, that is called as non-linear devices. That type of devices which is not applicable to the Ohm's law, that type of elements which is not applicable to the Ohm's law. Okay, if suppose the Ohm's law is applicable, they must should be contains constant temperature, as well as which is the Ohm's law which is applicable only for the linear devices only, linear devices only. So this is called as Ohm's law. So Ohm's law formula is given as I is directly proportional to V. I is directly proportional to V at constant temperature. Okay, at constant. So what is the room temperature here? 27 degrees centigrade. At constant temperature, the current, the applied current, which is directly proportional to the potential difference across the conductor. Potential difference across the conductor is called as Ohm's law. Is called as Ohm's law. Okay. As well as, so coming to the law of resistance, as well as coming to the law of resistance. Law of resistance like a property of resistance. Okay. So coming to the law of resistance, which is based on, so for example, which is based on mainly length of the conductor. Okay, for example, if the resistance of the conductor is increasing, if the resistance of the conductor is increasing, whatever the length also increasing. Okay, for example, if the length is increasing from, so one place to another place, the length is increasing, length of the conductor is increasing, then automatically the resistance, the property of resistance also increasing. Then the property of the resistance, that is given as R. The property of resistance also increasing. Due to that increasing of resistance, the length also increasing. Already know that. Due to that resultant, the area of cross section, is decreasing. Due to the resultant, the area of cross section is decreasing. So because of the increasing of resistance of the total line, then automatically the area of cross section is decreasing, which is very, very important factor. Okay, whenever the increasing of resistance of the total entire length of the line, then automatically the area of cross section, which is indicated as A, which also automatically decreasing, Okay, so from this simple you can give the formula represented like R is equal to rho L by A. R is equal to rho L by A. Let us consider capital A is the best. Capital A is the best. So R is equal to rho L by A. So this is the formula for the property of resistance or law of resistance. Okay, if increasing the resistance, then whatever the area of cross section will be gradually decreasing. If increasing resistance, as well as the length of the conductor also automatically increasing, as well as the resistivity. Here rho is there, the resistivity also increasing of the total entire line. Okay, for example, this is conductor. Okay, so length is increasing, this is L is increasing, then automatically resistance increasing, then area of cross section is decreasing. Area of cross section means this is the area of cross section. Okay, so this is decreasing, length is increasing. For example, so best example for this conductor law of resistance. For example, if I want to take one rubber, if I increasing the tension of the rubber, if they increasing tension means tension the rubber, then automatically the area of cross section of the rubber will decreasing, then the area of the cross section will be decreasing. Okay, so అది తిన్నుగా అవుతుందండి. సో మనకి ఎప్పుడైతే ఇంక్రీజ్ చేస్తున్నామో దాని సైజ్ అనేది ఆటోమేటిక్గా ఏమో ఏరియా ఆఫ్ క్రాస్ సెక్షన్ మనకి తగ్గిపోతుంది. సో సేమ్ రూల్ ఈజ్ బేస్డ్ ఆన్ హియర్. So if another increasing the length, then automatically area of cross section will be decreasing. Here the total area of cross section of the total conductor will be decreasing. Okay, so this is the property of law of resistance as well as Ohm's law. So thank you very much. So for more updates, please subscribe my channel. We can make the different types of videos. Please support me. Thank you.